promote the pre-commercializations and commercializations of the products. And my field actually mainly focus on medical imaging. We use a lot of medical images in our research, and some of the basic modalities in today's standard is the X-ray, the CT, the fluoroscopy, the MRI, and the fluorescence. Okay, so these are a few types of modalities available here, and we mainly use it. And in today's standards, 2Ds we mainly use it in like for the dental, the neo-osteoarthritis, while the 3Ds we use it like for the brain mainly. And as long as these imaging modalities dimensionally increase, actually we can extract more information at the expense of more computational power, right? So this is what we have to face. There will be always a trade-off in between the data that we are going to use and the computational power that we need to spend on it. Okay, so in this medical imaging, basically there are two streams here. One is called the classical medical imaging, which involve mainly the traditional machine learning use of technologies like your SVM clustering, which is relatively outdated by today's standards, but they still have their own charm in the sense of their property. And I started to work on this kind of traditional medical imaging before we started to use the GPUs in like the UNet, ResNet, and now the VLM. Okay, and there are a few types of traditional medical image computing approach, which is the region-based, the graph-based, model-based, and lab-based. So maybe you heard about that because it is relatively unused, and we only use that for teaching purpose for the students to understand the theory. But the thing in comparison with the deep learning is that all these kind of methods, including the machine learning, they actually have a very strong mathematics foundations, in which it becomes more transparent in the sense that we can actually deduce the solutions come from this traditional machine learning approach. Okay, and this is how we started our research, and I mainly focus on random walk, which is a kind of graph-based. So graph-based approach, they have a different sense of use in that they are governed by the graph properties, and then we come out with some of the pre-processings. We use the histogram-based curve in order to manipulate the property of our medical image. So when we talk about research by using a certain type of data, and in my case by using the medical data, the first thing is actually not about what kind of algorithms or models that we are going to use, but it's more about what is the property of your data. So to do a good research, actually we need to understand the characteristics of our data. And in the sense of medical data set, actually they are grade level, so we focus more on like the texture, the intensity property, and to a higher level like the statistical property of the data itself. And then we can start to think what kind of manipulations or modifications we can do to improve the property of our data. And that will depend on the research need of your study. And in this case, actually, we started the work by studying the neo-osteoarthritis. So one of the main problems with this MRI image at that time is we don't really get a very strong boundary delineation in between the bone and the cartilage. So the doctors asked whether there is any way to increase the contrast in between these two. So we find out through the pixel distributions, and then we can manipulate this distribution of pixel histogram by using the basic curve. And this is the starting of the research. And to some extent, a very basic research, especially into the standard, because by today's standard, medical image has become very high resolutions, or we can use the GAN to improve the resolution of the image. Okay, but the point that you all have to understand is that, especially for data science students, most important and the first step is not really about what kind of algorithm that you're